we are going to be starting Unit 5 on trig functions. So you'll be able to watch this video, take notes along in your notes packet, and then you can take a look at all of the assignments that will be due for this unit. This second page is going to be a good resource for you to use. It's called the unit circle, and we'll explain more as we start to fill in some of those things, but just know that that is a resource that you'll be able to use. This first learning target is you can change the measure of angles to and from radians and degrees. So if you know an angle in radians, can you tell me how many degrees it is, and vice versa? If you know how many degrees an angle is, how many radians would that angle be? Let's start off with some basics of angles. There's multiple parts to an angle. There is the original ray, that's also called the initial side. That ray does not move. That will stay in place. And then the terminal side is this angle that decides actually if it's going to be a smaller angle or a larger angle. That angle is called the terminal side. We are going to start putting these angles onto the coordinate plane, and so that initial side is going to start on that x-axis, and the terminal side will be any place else. And that's what's called standard position. So a standard position, an angle, is said to be in standard position when its initial side runs along the positive x-axis. So the initial side is running along that positive x-axis. Both of these angles, so this angle A is in standard position, and this angle B is also said to be in standard position because that initial side is on the positive x-axis. B is a special kind of angle. It's called a quadrantal angle because it makes exactly that quadrant of the coordinate system. We are going to be dealing with both positive and negative angles. If the rotation of an angle is counterclockwise, that's how we're going to measure angles being positive. So if this angle is going in the counterclockwise direction, that would be a positive angle. So we could estimate that this angle is about 60 degrees, which would make the clockwise direction be negative. So we could look at that angle and say that that is a 60-degree angle, or that it would be a negative 300-degree angle. So an introduction to radians. The two most common units used to measure angles is degrees and radians. And it is going to be important that as you do some of these calculations and you're using your calculator, that your calculator is set to the right mode. So I would always make sure your calculator is in the right mode. And how you can do that, if you take a look at your calculator, if you just are on the normal screen, if you press that mode button, the third one down will tell if it is in radians or degrees. And so if you want to be in degrees, then just make sure you press enter, and now you're in degrees, and then you can quit and then do whatever type of calculation you need to do. But just make sure that your calculator is set to the right mode. The definition of a radian is that a radian is the length of the arc or outside of the circle that is equal to the radius of the circle. So if we use this unit circle where the radius is exactly 1 unit, that's why this point is at 1, 0, because we go right 0, up 1. That's why this point is at 0, 1, negative 1, 0, and 0, negative 1. So if this is 1 unit and that's the radius, this distance right here, this angle, if that is the exact same length as the radius, that would be considered 1 radian. So you can measure angles in degrees, or how long is that outside piece? That would be 1 radian. So we are going to have to go back and forth between radians and degrees. If you know how many degrees an angle is, you should also be able to tell me how many radians and vice versa. So this relationship is important. One complete revolution is going to be marked by 360 degrees. And so that's where we get this relationship of 360 degrees is 2 pi. Now where is 2 pi coming from? It's coming from the fact that this full circle is 360 degrees. Well, if we want to talk about the length of that arc and how many radians that is, that's 1 radian. It looks like we've got a couple more radians going all the way around the circle. We can figure out what is the circumference of that circle. Well, the circumference is 2 times pi times the radius. And so if we're going to use this unit circle and say that that radius is 1 unit, then we can say that the circumference is 2 times pi times 1, or that that circumference is 2 pi. And so that's where they're getting the fact that the circumference, 1 full revolution, is 2 pi. And so 2 pi becomes equivalent to 360. And so that's what we've got right there. Okay. This unit circle that's all blank, all the measurements have been taken out. We're only going to fill in a couple of them, and that's that same chart that was on the second page, or the back of the first page of the notes. And so we can fill in that 0 degrees would be 0 radians, and 360 degrees is going to be 2 pi radians. So we're going to pick out a couple of important other angles and figure out what's the equivalent between degrees and radians. How can we go back and forth? So if that full 360 degrees is 2 pi radians, we can figure out if we only have 180 degrees, if we only have that one circle, how many radians would that be? Well, if the full circle is 2 pi, then half the circle is only going to be pi radians. Okay. And we could also take the angle of 90 degrees and say 90 degrees goes right there. And remember, I'm always starting on this initial side, this positive x-axis, and I'm always going counterclockwise. So 90 degrees would be right there. So that 90-degree angle would end up being pi over 2. It's exactly half of 180. So since 180 was pi, if we take 180 and divide it by 2, and we get 90, we can take pi and divide it by 2, and we're left with pi over 2. So I guess we can also fill in this 180 degrees is pi radians. And we'll talk about exactly the coordinates later. We won't worry about that for now. So we want to come up with this rule. How do we change from degrees to radians? If we know that 360 degrees is 2 pi, and 180 degrees is pi, and 90 is pi over 2, how can we go from degrees to radians? And we're going to have to multiply by pi over 180. And so that's a rule that I would highlight. Okay, so changing from degrees to radians, I would highlight that as something important. You have to multiply by pi over 180. So if we are going to figure out, well, how many degrees is how many radians is in 1 degree? We can use that rule and say I'm going to multiply 1 by pi over 180, and we just get pi over 180 degrees. Sorry, radians. So 1 degree is going to be pi over 180 radians. That's going to be a pretty small number. Okay. So let's take a look at some of these angles. If we have a 60-degree angle and we want to figure out how many radians is in 60 degrees, we would take that 60 degrees and I'm going to multiply it by pi over 180. And so when we're multiplying fractions, we're going to multiply the numerators and get 60 pi and multiply the denominators. So we'll write that over 180. And we can simplify 60 over 180 as 1/3, or pi over 3. So we've got 1/3 pi, which we can write as pi over 3. Okay. We can do the same thing with 270 degrees. We will take that 270 degrees and we are going to multiply it by pi over 180. So we get 270 pi, oops, 270 pi over 180. And that will simplify to be 3 pi over 2. If you simplify 270 over 180 and get that into its simplest fraction, it'll be 3/2. And so if we want to try to find some of these measures on that unit circle, let's start with that 270 degrees. 270 degrees would be 90 plus another 90, 180 plus another 90. So 270 degrees is going to be right down here. And we can say that that is 3 pi over 2, or 3/2 pi, or 1.5 pi, which makes sense that if 90 degrees is half a pi, we've got half a pi, 1 pi, and then 1.5 pi so that we can finish it off with 2 pi for 360 degrees. Okay. If we also want to label the 60 degrees on that drawing, there's only a couple drawn out there. We're going to go that that's 30 degrees, 45, and 60, and we'll talk about why those are special angles later, but that would be the 60-degree angle, and so we could also label that as pi over 3 radians. We also want to be able to take an angle that's measured in radians and figure out approximately how many degrees that is, especially because you are more comfortable, you've had a lot more experience with measuring angles in degrees. You want to be able to picture how many degrees is in 1 radian, or how many degrees is in 5 pi over 4 radians. So to go from radians to degrees, we are going to multiply by the reciprocal. So instead of multiplying by pi over 180, you are going to multiply by 180 over pi. And that will take you back to degrees. So for example, if we know we have 180 or 1 radian, and we want to figure out how many degrees that is, we'll multiply 1 by pi, or 180 over pi, and we get an answer that is approximately 57.3 degrees. And you can look, if you look back at the drawing at the top, where we said that that 1 radian was the same length as 1 degree, I think that that looks about reasonable. That would be about 57 degrees. So 1 radian is approximately 57.3 degrees. Okay. So we can use that rule also to find out how many degrees would be in 5 pi over 4 radians. So I'm going to take that 5 pi over 4 radians, and I'm going to multiply it by my rule of 180 over pi. Okay. So when we do that, we multiply the numerators, we get 900 pi over 4 pi. And though if we simplify that fraction, the pi's are going to cancel. And 900 divided by 4 is 225. So we changed from 5 pi over 4 radians is equivalent to 225 degrees. So if we find that on our unit circle drawing, 225 degrees is going to be 180 plus another 45 degrees. So we can label that as 225 degrees. And I'm also going to write that in as 5 pi over 4. So we're starting to get that thing filled in. We're not going to have it all the way done. Then we also want to figure out how many degrees is in 4 pi over 3. And so some other strategies that you'll develop is you can look at that and see that that is more than pi. So on that unit circle, pi was exactly 180 degrees. So we know that 4 pi over 3 is going to have to be something more than 180 degrees. So again, we can use that conversion rule. We're going to take 4 pi over 3 and we're going to multiply it by this 180 over pi. And we are going to get 720 pi over 3 pi. And again, that pi on the top and pi on the bottom are going to cancel out. We're not going to have pi in our answer anymore. And 720 divided by 3 is 240 degrees. So 4 pi over 3 radians is equivalent to 240 degrees. So let's find that on our unit circle. 240 degrees. Again, we always start at this initial side and we go counterclockwise. So we'll go around past 180 and 240 is going to be 60 more degrees. So all the way over to here, we've got 240 degrees. And that was an angle of 4 pi over 3 radians. So hopefully now you can go back and forth between radians and degree measures. And your assignment is on page 244, number 6 through 20, and 246, 66 through 70.